right, so we are going to be talking about Bohr diagrams today. The Bohr diagram is another way for you to look at an atom and get us ready to start looking at how atoms bond with each other. So let's get started. Remember that you should be filling in your note sheet as you begin. The Bohr diagram sheet side is the one that says Bohr diagrams and Lewis dot structures at the top. All right, so the first thing that you need to do with a Bohr diagram is you need to find your element on your periodic table. At this point, your periodic table should be nice and pretty with all of the colors that we've been working on for the past few days. What you need to do next is determine the number of electrons. We already know how to do that. Remember, it's the same as the atomic number, and then that's going to tell you how many electrons you're going to draw. For example, carbon, its atomic number is 6, so that is telling you that there are 6 electrons. What you need to do next with Bohr diagrams is you need to look at the period that your element is in. Remember that periods are horizontal, so they start at the left and they move to the right. This picture does a really nice job kind of highlighting the different periods with the different colors. Remember the lanthanides and the actinides are beneath the periodic table just because it'd be too big to have them in their period. All right, so when you're looking at the periods, the elements in the first period, so that would be the top 2, hydrogen and helium at this point, you are going to know that those elements have 1 energy level. The first period, they have 1 energy level. Elements in the second period have 2 energy levels, and so on, okay? The third would have 3, the fourth would have 4. All right, so we got that. So we're going to use carbon again as our example. So what you're going to do, and this is going in the first box in your notes, that empty box, you're going to draw a circle. And the inside of that circle is representing your nucleus. So the inside of your circle, you should write how many protons and how many neutrons there are. That's a given to you. And the second step is we know that carbon is in the second period. It's in between boron and nitrogen. So what we need to do then is we need to draw 2 energy levels. So now I drew 1 circle around my nucleus, and then I drew another circle around my nucleus. So now I have my 2 energy levels. So I'm at a good place. What we need to do next is add our electrons. As we know, carbon's atomic number is 6, so there's only 6 electrons that we can work with. When we're starting this, you always start at the innermost shell, the shell that's closest to the nucleus, okay? So in your second empty square in your notes, draw your nucleus again with your 2 energy levels, and we're going to start to add our electrons on our first energy level. The first energy level can only hold 2 electrons. That's it. That's maximum capacity. So what we're going to do is we're going to take 2 of our 6 electrons, and we're going to draw them. So you'll have to add that to your drawing in the second box. When I do my Bohr diagrams, I always start at 3 o'clock, and then I move to 9 o'clock. This is only on the first level. So I start on the right, and I move to the left. Right? So this should be your second box. Now we're moving on to our third empty box in our notes. We know that we have already drawn 2 electrons on that first energy level, and that's all that it can hold. So now we need a place to put the other 4. What you're going to do, you're going to put those in the second energy level. So you're going to add 1 electron at a time. You're going to start on the right, and you're going to go counterclockwise. So you're going to start at 3 o'clock again, then move up to 12, 3, and 9. So you should add those 4 outer electrons, called valence electrons, to your Bohr diagram in that third box. All right, so now when you look at your final picture, you should have 6 electrons total. You should have 2 in the first shell, 4 in the second shell. All right, the next section of notes, we want to remember that only 2 electrons can fit into the first shell. Only 8 electrons can fit into the second shell. The third shell can hold up to 18 electrons, but the first few periods only really use 8. So we kind of just know that they can hold 18, but we just kind of work with 8 in the third one too, which I know is a little confusing, but we won't do too many elements that are really high up on the periodic table. All right. So now what you have is you have your Bohr diagram worksheet. And that is the one that says Bohr atomic models up at the top. And it kind of has a weird miniature version of the periodic table with all these circles. So what I want you to do at this point is to pause the PowerPoint and start adding the electrons as you go through. Okay, so don't forget to add the symbol, the atomic number, and the mass number for all of the atoms as well. Once you're done with hydrogen, helium, oxygen, aluminum, neon, and potassium, then you can come back and check your answers. All right, so at this point, you should have tried all of those elements on your own. Let's see where you're at. You could have also maybe wanted to get started and just want to check some of them. That's okay too. So hydrogen. Hydrogen is a very unique element. It only has 1 proton and 1 electron. So hydrogen in that in the shell, the first shell, just has the 1 electron. Helium has a full outer shell because remember the second shell can only hold 2, so it's very happy. Oxygen has 2 in the first shell and 2, 4, 5, 6 in the outer shell, so it would need 2 more to be complete. Aluminum is going to have 13 electrons total, so you have a full inner shell, a full second shell, and then 3 in the third shell. That gives you 13. Neon. Neon is a noble gas. It's very happy because all of its kind of openings for electrons are totally full. So you have 2 in the first ring and 8 in the second ring, so you have 10 total. And then you have potassium. Potassium has a lot of electrons. There's 19. So you have 3 full shells, so 10 or 8 and 8, 16, 17, 18. But then, since it has 19, you actually need a 4th shell. So that's where you take this electron, you put it here. And this is why potassium is so reactive, because it wants to kind of ditch this last electron and have a full shell and kind of become more like argon. All right, so make sure that you can make Bohr diagrams for the first 18 elements. This is what you should have been working on. Make sure you have all of these kind of going for practice. There are some directions here up at the top to help you remember. I would get about half of them done and check in with me to see if you're on the right path. Please ask if you have any questions. Thank you.